In this video, we're going to talk about factoring some more, and we're going to use division to factor. Right? We're going to show how division can be useful to factor polynomials. All right, first let's do a real quick recap about what factoring is. Right? And you should remember that the word factor as a verb means to express a number as a multiplication problem, to express it as a product. Right? So if I ask you to factor the number 35, right, I'm basically asking you to express 35 as a multiplication problem. Right? And that's super easy. Right, because we know 35 is 5 times 7, right? So that's how we would factor 35, is 5 times 7. All right, but let's look at a little bit harder one, right? 685. If I asked you to factor 685, right, would you be able to do that? Right? And it is a little bit harder, but we could still do it, right? But the tricky thing is that off the top of my head, I don't know two numbers that multiply to get 685. Right, so it's not as easy as, say, 35. All right, but we could still do this, right? Because 685, we know that since it ends in 5, we know that it's divisible by 5. Right? In other words, we could say this. We know that 5 is a factor of 685. Right? So in other words, we know that 685 times 5, or 685 divided by 5 will give us a nice number. Right? So how does that help us? If we know that 5 is a factor of 685, what that basically tells us is that the factorization of 685 would be 5 times some number. Right? Because we know 5 is a factor, that means to factor 685, it would be 5 times something. Right? So then all we got to figure out is what that something is. Right? How would we do that? To figure out what this something would be, all we would need to do is use division. We would just need to do 685 divided by 5. Right? Let's go ahead and do that division. Right? 5 goes into 6 one time. Right? So 1 times 5 is 5. And if we subtract that, we get 1. Bring down the 8. 5 goes into 18 3 times. So 5 times 3 is 15. And we subtract that, we get 3. And bring down the 5. How many times does 5 go into 35? 7 times. 5 times 7 is 35, and there's no remainder here. Right? So the answer to factorizing 685, to factor 685, would be this. 5 times 137. Right? That would be the answer. Okay? And we know that that works because 685 divided by 5 is 137. Okay? All right, so let's take that idea and apply it to this polynomial here. Okay, we have this polynomial, 3x cubed plus 8x squared minus 33x plus 10, and we want to factor this. Right? And you might think, oh, there's 4 terms here, so let's use grouping. Right? Let's see if that gets us anywhere. So if I were to use grouping here, what could I pull out? What could I factor out from the first 2 terms? I could factor out an x squared. And then I would have 3x plus 8 here. How about in the back? Well, in the back, all I could pull out is a negative 1. And then I have 33x minus 10. Right, but wait, you should notice the problem here, because this 3x plus 8 is not the same thing as 33x minus 10. Right? And as you recall, you can't use factoring by grouping when this term does not match this term. Right? So this problem can't be done using grouping. You cannot factor this using grouping. So we kind of have to do something different. We got to kind of approach this a different way. Right? And as it is, right, you don't have enough information to do this just yet. Okay? Let's kind of restart number 3, but I'm going to give you a little bit more information. All right, so let's restart number 3. Right, we still want to factor the same polynomial. We want to factor this, 3x cubed plus 8x squared minus 33x plus 10. But now I'm going to give you a little bit of information, a little bit more information. I'm going to tell you that 3x minus 1 is a factor of this polynomial. Right, what does that mean? That means that that means that 3x minus 1 times something, 3x minus 1 times something would get me 3x cubed plus 8x squared minus 33x plus 10. Right? Basically, that in the first step of factoring this polynomial, right, we should have 3x minus 1 times some other factor. right? Because if you multiply those, you'll get back to 3x cubed plus 8x squared minus 33x plus 10, right? So how do I figure out what this would be? And the answer is we're going to use division. Right, so what we need to do is we need to divide 3x cubed plus 8x squared minus 33x plus 10. We need to divide that by 3x minus 1. All right, let's go ahead and do that division. Right, so how many times does 3x minus 1 go into 3x cubed plus 8x squared minus 33x plus 10? Right, well, the first part here, if we look at the first term here, 3x going to 3x cubed, that's going to go in x squared times, right? X squared times 3x minus 1 is going to be 3x cubed minus x squared. Okay, and then if I subtract this, what do I get? I get 9x squared. And let's bring down this negative 33x. All right, so now 3x minus 1 going into this, 9x squared minus 33x. Right, that's going to go in positive 3x times. So that's going to be, now if we multiply 3x by 3x minus 1, that's going to give me 9x squared minus 3x. All right, let's go ahead and subtract. Right, when we subtract that, that's going to give me negative 30x. And then let's go ahead and add 10, or bring down this 10. All right, now 3x minus 1 going into negative 30x plus 10. That's going to go in negative 10 times. Right? So 3x minus 1 times negative 10, if we multiply that, we should get negative 30x plus 10. Okay, and then if we subtract this, we end up with 0. We end up with no remainder. Right? And if we think about it, that makes sense. We shouldn't get a remainder because we know that 3x minus 1 is a factor, meaning that 3x minus 1 should go into this polynomial evenly. We shouldn't get a remainder of 0. We shouldn't get any remainder. So when you're doing these problems, if you get something, a remainder other than 0, you should know that you did something wrong. Okay? All right. So that tells us that the first part of our factoring, that if we were to factor this, it would be 3x minus 1 times this, x squared plus 3x minus 10. Okay, so the first part of our factoring is done. Let's get some more room here. All right, so the first part of our factorizing is that if we factored 3x cubed plus 8x squared minus 33x plus 10, we would get this, 3x minus 1 times x squared plus 3x minus 10. Okay, but let's take a look, and let's just make sure if there's anything else we can factor. Right? And it turns out this problem we can do a bit more, because if we take a look at this trinomial, this is a trinomial that we could factor. Right? Let's go ahead and factor that off to the side, or start our magic x here off to the side. Right? 3x on the bottom, and then negative 10x squared on top. Right? And the two numbers here that multiply to get negative 10x squared and add up to be 3x would be 5x and negative 2x. So we can still do a bit more factoring, right? Let's try to finish this up. So this first part is going to stay the same, 3x minus 1. And then let's use our grouping method here. So we got x squared plus 5x minus 2x minus 10. Right? And then we can factor these two terms and these two terms. Right? Let's leave this 3x minus 1 alone. And then let's factor this. We can pull out an x times x plus 5. In the back, we can pull out a negative 2 times x plus 5. So we end up with 3x minus 1 times x minus 2 times x plus 5. Now we have this completely factored. Here's our answer.